Okay, guys, so we're getting into descriptive statistics here. We've kind of introduced the terminology, the concepts to you now. So now let's get into the descriptive part of this. And here we are talking about how to summarize our data into tables and graphs. So this is where, we're going to introduce the different types of graphs we can create based on the type of data we have, the different types of tables we can create to, basically organize our data. So now you can have, and we had talked about qualitative and quantitative variables. Now we're getting into qualitative and quantitative data. See that better. Okay, so first thing we're going to talk about is how to take a frequency distribution for a qualitative data. So basically, remember qualitative was based on some kind of, oh, that word just flew out of my mind. Like attribute, I think that's what the definition had used in chapter 1. So it's got to be something that can be measured, that we can categorize or classify an individual for. So here we're talking about frequency distribution lists each category of data and the number of occurrences for each category of data. So basically, how many times does that same category occur? Omar, I'm not sure what you are doing, but I have a feeling it's not password. Okay, you are on the textbook?
Typing down.
Okay. So look at the type of data we're talking about here, guys. We're in this example, we're saying there's a physical therapist who wants to determine the types of rehabilitation required by her patients. So there's a random sample of 30 of her patients, and she records the body part that requires rehabilitation. Because again, we're talking about physical therapy over here. So you can see in table 1, all the different body parts for the 30 patients who require PT. So you've got back, wrist, elbow, hip, neck, shoulder, hand, something else. Wrist, I think I already read that. Anyway, so you can then see, okay, there's a lot of repetitions for the different types of body parts that the patients require physical therapy for. So we go ahead and start tallying. Okay, so how many times did we have the back? How many patients were basically going to need physical therapy on their back? And you can see once we tally that, it comes out to be 12. And obviously that would be, 30 is not a very large number. So we can say, okay, we've got back, back over here, back over here. So you take all the occurrences and then you count, okay, how many times does that reference come out to be? And you can see there are 12 patients who needed physical therapy on their back. Then we go down and we say, okay, wrist. So how many people needed physical therapy on their wrist? So we've got wrist, wrist. Okay, so apparently it's only 2 people who need wrist, right? So you basically take each of the words in this case, those are our categories, and then we see how many people need the physical therapy on that, and that's basically how you come up with your frequency distribution table. So this is what every now and then that textbook does not like to move forward. Not sure why it does that. your frequency. The frequency distribution table basically would be table two, except we wouldn't have that middle column where we did all the tallying for the different body parts. So you would basically just have one column where we would have the body part that needs physical therapy, and then the other one would be the frequency column. The tally is more like a sketch, rough work that you do while you're trying to figure out, okay, how many of the patients needed that kind of physical therapy. Now, the other one we talk about is a relative frequency table. And a relative frequency table, basically, as you can see here, is you take the frequency for that particular category, and then you divide it by the total number of data items that you had in your data set. So remember, this was based on 30 patients. So we would say, okay, there were 12 people who needed physical therapy on their back. So that would be 12 for that category divided by the total number, which was 30. So that would be the sum of all frequencies. And that's how we would calculate a relative frequency distribution. So same example that we saw with the PT. And then you can see what the body part was, what their frequency was, and then to calculate the relative frequency. So you will see on the bottom here, we have the total. So you take each of the frequencies for each category divided by the total. We do write relative frequency as a decimal answer. Very rarely do we leave it as a fraction. Every now and then you may see relative frequency as a percentage, but mostly you want to leave relative frequency in its decimal form and not even percentage, because we do try to leave them in, it's not going to tell you the definition, but yeah, the normal way is to leave it as a decimal, and you will see that's what we did here in this table. So there were only 2 people out of 30 who needed physical therapy on their wrist. So you can see that gives us a fraction of 2 out of 30, which is 0.0667. And then you can see for the other body parts, elbow was only 1. Knees were 5, so that's 5 out of 30, which gave us a relative frequency of 0.1667, so on and so forth. Now, you should notice that the total of the relative frequency column is adding up to 1, because that's all 30 of the patients who are taken into consideration. So your relative frequency, now there can be a little bit of a rounding error. So, depending on how you round your relative frequency, you may get a total of 0.99999, right, instead of 1. Every now and then you may get a total of 1.0001 or something like that. Again, that can just be a rounding thing depending on how you rounded your relative frequency. But obviously, as you can imagine, the closer you are to 1, the better your accuracy is going to be. And of course, in this example, you can see our relative frequency column did add up to a 1. So we know the rounding in this case worked out nicely. So that's how we create relative frequency and basic frequency distribution table. So let's take a look at a quick example here before we get into the graphic side of things. I'll just pick an example from the Let's see. Okay, so as you can see, this one is talking about a phlebotomist draws the blood of a random sample of 50 patients and determines their blood types as shown. So we want to start out by creating a frequency distribution and a relative frequency distribution over here. So I am going to copy this, and then you guys are going to help me create our frequency distribution table. Um, so obviously, we're talking about blood types over here. So our category can be blood types. Uh, for now, we can create a section for tally, and then we'll of course do a frequency column. And then we will do a relative frequency column. So first of all, how many blood types do you see in that table? And let's list them. Okay, which ones? Um, Okay. Let's do a tally here. Um. mm, So let's see, we've got one O, we've got one B, one A, another, and of course, you can do this on paper by hand. I'm just using one as our tally marker, so that can be two, right, for O. So at this point, we've got O, B, A, B, the first four of these. And remember, the one I'm just using as these tally marks, okay? They're not a count, so it's not like we have 11 votes. Just be careful about that. So take a minute and let me see what your total comes out to be for each of the blood type. And if you can only use ones as a polynomial. Now remember, there's a total of 50 patients, so you should not have a total for the frequency getting any larger than 50. Again, as I was saying before, make sure your total will add up to 50 because there's a total of 50 patients in there. Are we looking? Good. Did our numbers add up to 50? Yeah? What did you get? So you've got one extra in there? Okay, we can try and figure out where that happened. Libni? 50? Okay. How many do we have for type O? Type O, you said 22. Type A? 18. 18? Anyone? Yeah, anybody who have a different number for O was 22, A is 18. So maybe that's where your extra is. All right, how many did we have for B? Six, okay, and then AB. So let me show you what I have. Okay, so you can see I had 17, and that's because afterwards I realized I left this A out over here. So I hadn't included him. So that was why I was at 17 instead of 18. So that A should be fixed. 17. And here's the other reason why I like using Excel or Google Sheets, because now I have all of my frequencies. I can go ahead and use the built-in function of sum, which acts as your total. So I can say, okay, I want to do a sum of that column, and you can see Google is kind of pretty adaptive of that because it's like giving me the suggestion, hey, is this the column you want to add? And I can say, yeah, sure, you're the column I want to add. And you can see that comes out to be 15. I can say, okay, this is where I'm doing the total. Okay. All right, and of course you can see that matches with now the numbers you guys gave. Now, for calculating the relative frequency, again, we can do this by hand, but again, with Google Sheets, we can go ahead and do it by using, just the program itself. So you can see it's asking you, do you want to do 22 divided by 50? And it's giving you the cell reference of L3 divided by L7. So instead of typing numbers, because I can type equal to 22 divided by 50, or I can use cell reference. And the idea of using cell reference where instead of typing in the numbers, and you can see right here at the top where that FX bar is, so you can see right here, I'm using L3 divided by L7 because that way, if my table changes, I don't have to go back and rechange the numbers in there. If you had 19, I had 17 for type A, once we go fix that, we wouldn't have to go fix the calculation for relative frequency because it's got the cell reference, not the actual numbers in there. And that's basically what we're doing throughout the entire column over here. So now you can see for finding out the relative frequency for type A blood, we need to take 18 divided by 50. So it's again giving you a suggestion, hey, are these the cells you wanted to look at? Then you can see same thing, 60, or sorry, 6 divided by 50. So yeah, that's the cell I wanted. For the next one, it's 4 divided by 50. And then the last one, you actually are going to add up to see it adds up to 1 if the rounding is done correctly, and you can see that adds up to 1. Now, if you wanted more than 2 decimal places, because that's kind of the default here, you will see there are these little arrows over here. So the left arrow is telling you you want to decrease the number of decimal places. The right arrow is saying we want to increase. So I can say, you know what? How about we do 3 decimal places instead of 2, because I just want to see if the rounding was done perfectly. And you can see the third decimal place has a 0. So our rounding obviously looks pretty good. So if you don't want to keep the zeros, you can go back and decrease it. If you want to keep the extra 0 in there, you can. It doesn't matter. So I would like you guys to obviously start practicing with, if you have Excel on your laptops, you want to use Excel. If that's a program you're comfortable with, you can. But if you're not comfortable with it, I am going to be using Google Sheets. So you can obviously use Google Sheets. And the way to get to it, it should be the same for you guys. You should be able to go, depending on how your browser is set up. Now, my browser is set up on my personal email, so it may not work. If you have it set up with your school email, then you can just go to that little, is that the waffle option they call it? The waffle menu thing, you go in there and you can find Google Sheets from there. So you can do it that way, or you can just type sheets.google.com, or is it google.sheets?
Google Sheets.
Just Google Sheets. I guess that works too, doesn't it? So I guess you could do. All right, anyways, so that's how you come up with your frequency distribution and your relative frequency distribution. Now, the good thing about doing this in something like Google Sheets is, because we're going to be creating our graphs here as well. We're not doing any graphs by hand. So we're not going to be, sitting and making the graphs like on a piece of paper. We're all going to be doing it right here. Right here within the program itself. So you can see that's the next thing we're getting up into, is talking about how to create different types of graphs. We're starting out with bar graphs. Now, when we're talking about bar graphs, basically the name kind of gives it away. You're going to have horizontal or vertical bars representing your data value. So they're saying basically a bar graph is constructed by labeling each category of data, which can be either on the horizontal axis or on the vertical axis. And then the frequency or the relative frequency will actually tell you what the length or the height of each of the bars should be. So rectangles of equal width are drawn for each category. And that's important, guys, that each bar that we're representing to use for the different categories have to be the same width. And that's actually something we will talk about when we talk about misuse of statistics again, right? Because by changing the width of the bars, we can actually create a bias in the visual sense, because then it may seem like, oh, I think this bar is thicker. Does that mean there's more data on this as opposed to a skinnier bar, because maybe there's not as much in there? So just visually also, we can create a bias. So that will be something we'll talk about. So again, rectangles have to be of the equal width. And then, like I said, the height is determined by frequency or relative frequency. So let's talk about the same example. Our physical therapist using the different body parts of 30 of her patients to see who needs the most help. So remember, the back pain was 12 people. That was the largest category we have. So look at how they are creating the graphs over here. So you can see the graph on the left-hand side is based on the frequency distribution. The graph on the right-hand side is based on relative frequency distribution, because they're telling you what that vertical axis is. So of course, your horizontal axis, you will see is based on the different body parts. The vertical axis for each of the graphs is based on frequency or relative frequency. You will also see there's a title to the graph because the idea is if you don't have the table from where we came up with these graphs, by just looking at the graph, you should know what you're looking at. So we should, if we didn't have those first two examples, the knowledge of those examples, by looking at the graph, we can see, okay, we're talking about types of rehabilitations, of course, some kind of exercise program, right? You can see we're talking about the body parts on the top bottom. They've of course labeled this as body part. And then you can see frequency and relative frequency. Now you should notice both graphs look exactly the same. Now, of course, the y-axis values are different, but look at how similar those graphs are. If I were to superimpose them on top of each other, they would look the same because obviously relative frequency is calculated based on the frequency. So you can see our tallest bar was for the back rehab people. Then you had knee as the second tallest category, or the second maximum number of people. Then you have shoulder. And then of course there was only one person for elbow, one person for groin, one person for neck. And then you can kind of see how that breaks out to be. So this is how you would create a bar graph. Now this is of course a vertical bar graphs because of course your bars are set up vertically. This example is talking about how you can use technology to come up with your graphs, and you can kind of see, the example obviously again looks very similar to the graph we just saw. You've got the frequency distribution on the left, relative frequency distribution graph on the right. So how do we create a bar graph for our example using the blood types here? So in this case, I'm actually going to delete that tally column because, like I said, that was supposed to be just a rough sketch, so we don't really need it. Okay, so how do we create our bar? So we will need to select the blood type column and the frequency column. And you're only going to where you have all the categories. You're not including the total line in that. Because otherwise what happens is it creates another column for you. And of course, we don't need a column for the total. So just the titles of the columns, the 4 categories of blood types and their frequency. And then there's 2 ways to get to a graph or a chart. Now you can see this little icon here. And again, let me get it. So there's this little symbol over here, which kind of looks like a very tiny bar chart, or you can go under insert menu option, scroll down to where you see chart. You can kind of see the word chart there and then click on that. Now, of course, Google will kind of say, hey, is this the type of graph you want? And you can see it went with a pie chart. And we're not really doing pie charts right now. So go under the chart type option here under your chart editor and select the one that looks like a bar graph. So you've got a vertical column chart. You can see there on the right-hand side. You've got a bar chart with horizontal bars on it. So I'm actually going to just show you how that guy will end up looking like. So let's see them there. So you will see what happens is on this type of chart, your blood types actually is on the vertical axis of the graph, and your frequency is on the horizontal. Now, if you wanted to change that, you can go under the y-axis, x-axis here, and you can say, you know what, I want to change this, switch rows and columns. The difference not. Okay, so it's not letting me do that. I might have to play around with it a little bit more. But anyways, I do not like the way this graph looks. So I'm going to go and say, hey, you know what? Just give me that vertical column chart, bar chart. And that actually looks a lot better. So you've got your blood types on the horizontal axis. You've got your frequency on the vertical axis. Now, of course, you will need to change the title because frequency versus blood types doesn't really tell us much. So we can double click on that and we can say this is types of blood. drawn, or, you know, whatever you wanna call it, that represents the value you are looking at. So you will see this is going to be our frequency distribution. Now, to be able to create a relative frequency, of course, you would again still need the blood types. And then we can say, okay, I want to select the relative frequency column. So I use the actual control key on my keyboard to select the two columns, since they're not next to each other. And then same process, you would go under insert, you would go under chart. And you can again see by default, it's selecting the pie chart, but we can say again, I want a column chart. And this time, you should notice that we have same graph, but this one is now based on relative frequency instead of frequencies. And I'm gonna move him next to the original graph we just did. And again, make my heading, the title of the graph match the other one. So this will be types of drawings. And under the customize option, you have other things you can do, you know, change the colors, make it look pretty. I'll let you guys worry about the cosmetic stuff there. So, you know, play around, get a little bit used to that, but you can again see type O is where we had the most number of people or patients whose blood was drawn. So that's our tallest column, which again, blood type O is more universally common, right? AB is one of the rarest blood types. That's why we only had 4 people out of 50 who had a blood type of AB. So you can see that's the shortest bar or column in our graph over here. But again, you can see how easy using technology makes the graphing process, right? Now imagine trying to do this by hand would still be here, just looking at the first example that we were doing. So I, again, want to reiterate, we will be using Google Sheets, and I do want you guys to get comfortable using the program for creating different types of graphs.
Did you select the blood types and the relative frequency?
So I started out by selecting the blood types till the AB. Then I use the control key on my keyboard, keep it pressed down, and then select the relative. Because they're not next to each other, right?
Yeah, I just didn't know.
So yeah, the control key is what helps you do that.
Okay.
Yeah, you're welcome. Or the other thing would be to write another table, and I'm like, why? We've already got it in there, right? Control key will help you. All right, questions on this one here, guys? Okay, so let's see, this was, I think, our third. Yeah, draw a frequency bar graph, draw a relative frequency bar graph. So we've got both of those. Now you will see here, you've got some other questions. They're asking you, according to the data, which blood type is the most common. So of course, the most common blood type here, obviously, is going to be blood type O, right? Because that's where you have the highest frequency of 22 out of 50 patients. Then the next example was which blood type was the least common? And you've already kind of talked about this, that would be blood type AB because that had the least number of patients in there. Now, option E is asking us, use the results of the sample to conjecture the percentage of the population that has type O blood. Is this an example of descriptive or inferential statistics? So take a minute. I'm looking at question E. Use the results of the sample to conjecture the percentage of the population that has type O blood. Is this an example of descriptive or inferential statistics? And again, we have looked at those definitions in chapter 1. So what percentage of the population do you think will have a type O blood type? Yeah. What percentage of the population would have blood type O? Yeah. Very good. That's coming from the relative frequency. 0.44 translates to 44%. So we would say 44% of the population would have a type O blood type. So is this descriptive or inferential statistics? Do you remember what those two definitions were? I think Omar said inferential. In section 1.1, you should be able to see this definition. Okay, so we've got two answers for inferential. What about the rest of you? Descriptive and inferential definitions. All right, descriptive or inferential that we're talking about from the table, we had 0.44 and we're applying that to the entire population and saying 44% of the population would have blood type O. Libni? Okay, Christopher? Cameron, right? You didn't answer. You said inferential, didn't you?
The only reason I would also say descriptive is because we used a table.
Very good. Yeah, so you could honestly make the argument that we did use the table. However, for that specific question, we're taking the result we did get from the sample using descriptive statistics, right? And we're applying it to the population. So in that specific instance of the question, it would be because we're taking the results from the sample and applying it to the population. So of course, you can see that's what happens in inferential statistics. All right, then let's see, they're saying part F, contact the local hospital and ask them the percentage of the population that is blood type O, why the results might differ. Okay, obviously that's not gonna happen today. All right, the last part is a pie chart. So some other types of graphs over here, guys. We of course have a Pareto chart, which is named after a statistician, I believe, from South America. I may be wrong in the country of origin though. Pareto chart is basically a bar graph whose bars are drawn in order from decreasing, from increasing to decreasing in order of frequency or relative frequency. So this would not be just randomly like we saw with the body part. Oh, that sounds so murderous. The physical therapy example, right? Where it can go up and down. But Pareto chart, you would actually organize it from the highest frequency to the lowest. So you can see now it's got that little tail kind of extension on the right hand side. So that's the only difference in the Pareto chart is you organize it from highest to lowest frequency. Now, if you are comparing two different types of categories, you can do side-by-side bar graphs. So you can see in this example here, we're talking in terms of 1990 and 2013. So this was the educational attainment. What level of education did people have? And you can see the two different years the comparison is being done to from 1990 to 2013. So this is what a side-by-side graph would look like. One color represents 1990, the other color represents 2013. And you can see now we can see some of those values stayed about similar, but then others, there's a big difference between the two years over time, how that has changed. I kind of already showed you the horizontal bars, but let's take a look at So a side-by-side graph with horizontal bars. So of course, you will see in the side-by-side or in the horizontal bars, your frequency or relative frequencies on the horizontal axis, and then your categories are on the vertical axis, kind of like what we had seen in Google Sheets. And then pie chart, think of a pizza, right? So pie chart is where the circle is divided into sectors, and basically each sector represents a category of your data, and each sector's area is proportional to basically your frequency or your relative frequency. So of course, as you saw in our example in Google Sheets, it was by default trying to give us a pie chart. So basically, again, we can just use the frequency with the blood types as our two columns, and then we can say, all right, insert a chart. And this time, since by default it gave us a column chart, we'll go select the pie chart, and you will see how different this guy looks, because you obviously do not have a horizontal axis or vertical axis. So this was again our title, so types of blood that was drawn from our patients. And you can now see by default, it's giving you a label. So it's telling you O was our largest category. Remember, the relative frequency was 0.44. So it's showing you 44% over here, which is so you can see that's the 44% for O. Then type A was our next one at 36%. Type B was the third largest at 12%. And then our smallest blood type was, of course, AB at 8%. Now you can make it fancy if you wanted to put the labels on the sections itself instead of having the lines point to it. You can go ahead and make those kind of changes in the customization. But basically, you can see the area of each wedge or each sector depends on how large the frequency or relative frequency for that category was. And then you can see largest was for type O blood, smallest was for the type AB blood, right? So that will be another way. So these are the types of graphs we would use when we're talking about qualitative data based on categories. When we are doing numerical examples, you will of course see we will start using different types of charts and different types of examples to show you what that might look like. And again, guys, I wanted to point out at the end of the section, they do have this little technology step by step. So they will walk you through some types of technology. So depending on what you are using, there's some steps for Excel. Again, it might look a little bit different for Google Sheets, but kind of on that same base there. All right, guys, so this was section 2.1. We'll pick up from section 2.2 next time. So for Wednesday at 2:30 p.m., your chapter 1 homework will close. So those of you who have not even started, there were 2 of you who have not started working on your homework. You have today, tomorrow, and Wednesday morning. Okay? All right, if you have any questions, stay back, guys. I'll be happy to answer them. And if not, I'll see you on Wednesday.
Okay. Wait.